Good evening, everyone, and welcome to another edition of the Dog Walk. This is actually episode 15. Forget what I said yesterday. Technically, I wasn't wrong, but unfortunately, one of the recordings that I had made, I found out when I was checking it out after uploading it to YouTube yesterday that it's not really usable, so let's just say that this is now going to be episode 15, and yesterday's very quick little chat will be episode 14. So, anyway, the dog walk is basically just my occasion to offload, hopefully daily, my thoughts of what's been going on during the day while I am out walking Mistra and Daisy, my two pups that you see in front of you, and hopefully some of this is thought-provoking or interesting to you. I never talk about or rarely talk about the same topics. I go from gardening to AI and everything in between, and I hope that you will enjoy the ride. So, speaking of AI, I think that's actually going to be the topic for today because I was watching a video from Asmongold again. Yes, I discovered him only a few months ago, but I have to admit I have been binging a lot of his content. I find that he actually has some pretty good takes on several topics. I agree with a lot of the stuff that he says, even if I don't with others, a few topics. But one of the things that he was talking about today was about big controversy that's currently going on with this game called Pal World, which is accused of all sorts of nasty things, as it is supposedly, or I guess the allegations are that it's basically just a ripoff of a Pokemon that was procedurally that was generated, that was made through the use of generative AI. And as I'm sure you know, AI is a big topic right now, especially when it comes to artists. Right, there was that big Screen Actors Guild and Writers Guild strike a few months ago, and I just thought that I would talk a little bit about this topic because some of the comments and opinions that were voiced by his readers mostly, or sorry, readers, his viewers mostly, were so completely wrong. They clearly showed that people don't understand what AI is or how it works, which I guess makes sense, right? Like, and I don't really understand how all the different art movements work, or how to differentiate from one another, this or that, just because I haven't looked into it. But at least I don't go around and voicing my opinions about these movements and these art styles. But that's beside the point. So I thought I would clear the air a little bit, because some of the things that Zach said also were a little bit, well, not quite correct. He was close, but not quite there on a few things. And I want to talk about this because I actually have some background in this. As I've mentioned in the past, I do have a degree in that stuff. I did a double major in computer science and space science, and I was actually lucky enough to, in my fourth year of university, and we are talking almost 20 years ago now. 2020. Yeah, actually, 20 years, 19 years ago now. I was lucky enough to study under one of the pioneers in the field, who was doing a lot of cutting edge research at the time for the military and the government on neural networks. So I feel I have some. Miska, we're going this way. I have some credibility, or maybe not credibility, but at least some of the prerequisite knowledge that most of the people who are commenting on this topic seem to lack. So yeah, that was a little bit about me. I obviously am not fully up to speed with all the latest and greatest capabilities of AI, but I do know enough about the basis of it and the basics that I feel I can shed a little bit of light on some of the topics. So the first thing that I want to discuss when talking about AI is I guess I'll try to debunk a few myths or misconceptions. So and starting at the basis is that AI is a very generic term that can mean a lot of different things. Come on, girls, let's keep going. We haven't been through this path for a little while, so the girls are probably going to be extra slow and stopping today because they have a lot of messages to catch up on. So sorry about that. But anyway, so starting with the basics, AI is not what most people think it is. I mean, this might be changing over the last year because of ChatGPT and those other, other tools that are now becoming, reaching the zeitgeist. So people are starting maybe to change, but I still don't think that people truly grasp the difference between a neural network, natural intelligence system, and an expert programmed AI. So what do I mean by that? Is that most people, when they think of AI, at the basics, they think of a system or some human came in and basically, as an expert, programmed all the possible scenarios and all the possible responses into the AI and told, when this happens, you do this. When the client in the chat window says that he has an issue with products XYZ, then you pull up these following questions related to products XYZ. If the client types in the word agent, you automatically redirect them to an agent, blah blah. Think of at the most basic level, kind of like the automatic telephone menus, right? To talk about your checking account, press 1. To talk about credit cards, press 2. To talk about mortgages, press 3, etc. Right? So that's what is called an expert system or an expert AI. And that was, there's something there, definitely. Pretty sure that's a rabbit. Daisy. Yeah, see, I can see the rabbit right there. I don't know if you can. Mistra making me. Okay, well, anyway, if I can. Hello, rabbit. How's it going, buddy? Cool. Anyway, so yeah, that was the first form of quote unquote artificial intelligence, and that's what people still kind of think it is. Even with generative AI being much more advanced than that, I feel that most people, in their mind, they're thinking, there's a human, there's the Wizard of Oz is behind the curtain, pulling the strings and telling the AI, how to react to prompts and, basically training up the system for responses. That's not really true, or at least that's not the final form of AI. The final form of AI, and I say the final form, this is something that, as I said, I was studying almost 20 years ago. The final form of AI is actually neural networks, and the best person. I'll mention this right away before I forget to mention it because it's important. The best person that you could possibly ever find, in my opinion, as a source for information on this topic, or to, you know, get the layman to understand it, is Ray Kurzweil. You might not know who he is. Ray Kurzweil is a very famous quote-unquote futurist, although I don't really like that term. He was one of the, for I don't know how many years, he was the chief technology officer of Google. So if I just mention that out of his biography, excluding everything else, hopefully that at least piques your interest to say, hey, maybe, you know, that Kurzweil guy must know a little bit about what he's talking about if he made it all the way to the title of Chief Technology Officer of Google, right? So, he's written several books, including one of my all-time favorites, which is called How to Create a Mind, where he explores technology, AI, progress, etc. And one of his main points, which is a little bit off topic for AI, but I'll still mention it since I'm talking about him at this point, is Moore's Law is not a new thing, and it's not something that we truly understand. So I can't really do justice to his entire argument that he elaborates in a 200-page or whatever, 200-plus page book in 2 minutes. But he shows in his book that the principle of Moore's Law, which is, you know, the density of transistor on a chip will double every 18 months or so, I think it was. That's just the newest iteration of the overall progress of human technology as far as we can go back. And he literally almost goes back to the invention of fire. And he shows that throughout human history, technological progress has been progressing, using the same word twice. And there's another rabbit right over there. So Daisy and Misa are probably going to go for it. Yeah. So basically, since the dawn of mankind, this has been the case. This has been a thing. And we are now realizing, my God, that rabbit really wasn't scared. Oof. Sorry for the shaky cam. As I mentioned before, Mistra is pretty strong. Basically, Moore's Law is just the computer version of it, where he noticed that transistors were doubling in density, which means, twice as many processors means twice as much capacity, right? That's just the latest iteration, but if you go back all the way to the first inventions, that's always been true. And his main point is goes back to exponential growth, another topic that I've spoken of in one of my previous videos. Maybe if I become a good creator, I'll put a little card or something to link you to that one. But yeah, his point is, because exponential growth is exponential, people always underestimate how fast things will change or how fast things progress, and it will just keep getting faster. I think anyone who's been around for a decade or two, or more than a decade, let's say, will see this in their daily lives, right? How fast is technology progressing now compared to when you were born? And because of the exponential growth factor, you are still projecting a linear growth in your mind when, as Gold was saying, in 200 years, there'll be computers that are that have brains like humans. I Sure, I agree with the second part of your sentence, but when you factor in exponential growth, think more like 10, 20, max 30 years. And that's just based on what we know now, not what's actually, how do I say, available in big universities and the public, unknown to the public, right? The bigger, whether it's the CIA or research university computers, all that stuff. We don't know how smart they are, but point is that it is very likely in my mind that there currently are computer systems out there that have the same processing power as a human brain. Now, does that mean they are as smart as a human right now? No, because all those systems are still limited by the domains which they can access, right? We can operate our body, and we're not limited. We're not just applied in doing image analysis, and that's the only thing that I do as an AI system, or optimizing production chains or whatever it is, right? We're more polyvalent. Can't say that word in English. Polyvalent. Anyway, we're more versatile. There you go. But that's just the situation now. And once we start to integrate multiple different AIs from different expert fields, when you integrate the vision AI that Tesla is developing with the optimization AI that Amazon is producing, and when you start to combine all those things with the neural nets that Boston Dynamics is creating to control their robots, you integrate all that together, and pretty soon it will be obsolete. Now, you might not believe that, so let me explain a little bit about what I mean by processing power. It's very simple. I'm not going to explain how our brain works right now. I'll start with processing power. So basically how we processing power is calculated is by the quantity of operations that can be completed within a certain period of time, right? So how that is done, how that is calculated is very easy, right? You take, let's say you've got 200 transistors, and I don't know why I said 200, let's pick round numbers. Let's say you have 100 transistors, and each transistor can do 10 operations per second. Well, that means that overall your system can do 10 times 100, right? So 1,000 operations every second. Okay, but how do you scale that? You can scale it by getting more transistors onto your system, so that every second each transistor that does 10 operations, well, now you have 200, so now you can do 2,000 operations per second. So your system is twice as capable or twice as smart as the other one. That's one way you can do it. But the other way you can do it is by taking those 100 processors or 100 transistors and speeding them up so that each of them can now do 20 operations per second. So now, you do the math and all comes as a wash, right? Both of those systems now can do 2,000 operations per second. Both of their systems are twice as capable as the previous one. And those are two very valid ways of increasing capability, right? So humans currently work in a way that we have a lot of transistors, of connectors, of neurons, right? But since our neurons are working at the speed, at chemical speed, these neurons are very slow. Whereas computers are building neural networks that have less neurons, right? Like we don't have computers right now that have as many transistors or processors right now that have as many transistors as there are in the human brain. Not even close. But these processors and transistors operate at orders of magnitude faster than our chemical brain, right? Speed of light or electricity actually compared to speed of chemical, right? So that's how computers. I realize I'm missing a whole bunch of context. I'm all over the place. But that's the first, I guess, part of the equation on how it's possible to make a computer that's as smart, as capable as a human, right? Or how to increase the capability of your system. You can go the nature route, which is make billions and billions and billions and billions of transistors that connect to each other slowly, or the way humans are getting around that is by having less transistors or connectors, but that talk to each other much, much, much faster. And in the end, as with the first example I gave there, it all comes out as a wash. That was weird. Now, sorry, something fell on me. As things are melting right now, it's close to freezing, or close to the freezing point. So anyway, now I'm sure you're saying, okay, but what does that have to do with humans, or how we understand, or, how does that make a computer smart like a human? Well, now let's go to the second part. So now that you understand kind of how to measure the speed or the capability of a system, let's talk a little bit about how human brains work. So you might think that your ideas come from nowhere, but you're probably not a brain scientist. What has been found out by in that field is that the way our brain works is that we have a whole ton of neurons. I don't know the number. I know it's not even billions. It's like orders of magnitude more than that. But the point is that we have tons and tons of neurons. And these neurons, these neurons, the way they work is they start off kind of independent. But as we grow and we learn, neurons build connections to other neurons. Hopefully you've done enough high school biology to that this is a refresher and not new information for you. But if it is, like, you can look it up yourself. The way it works, right? You've got the nucleus of each neural cell. Each neuron creates a bunch of, I believe the term is dendrites, which are basically the links. And these dendrites connect to dendrites from other neurons. And that's how, information and electrical signals get passed in our brain. Oh, I need to get out of here. This is way too dirty. So that's how it works. Now, it's a lot of information to try to organize, especially assuming no prior knowledge. And Mistra is stuck with her leash. Let me fix that. Mistra, lift up your... Yeah, there you go. Okay, freedom. Okay, so where was I? Yeah, so that's the basic component of the brain is a neuron, and the neuron has connectors that connect to other neurons. And how our brain works is that there's it uses, oh my, I don't want to explain ion channels and all that. The best way to the simplest way, not the best way, simplest way to explain it is that each connection to a neuron, if, or between neurons, those dendrites, if you use it, that path becomes reinforced. Imagine a path that you're making through a forest, right? The first time around, there's brush everywhere, and it's very difficult, and you need to do a lot of effort to get from point A to point B. But once you've gotten from point A to point B once, now the path is a little bit clearer, right? So the next time you go from point A to point B, it'll be a little bit easier. And then you'll clear a little bit more of the resistance, and then the next time it'll be a little bit easier, and the time after that a bit more and a bit more, until eventually the path becomes like this, a nice paved road, and the connection is super easy. Now the opposite is also true, right? If there's a connection that is not useful, and a path that you don't walk, well, eventually the forest regrows, and the path becomes much more difficult to pass again, up until a certain point where, if this path, or in this case this connection between neurons, is not used for long enough, it becomes trimmed and pruned as it's in excess and not necessary, and your brain doesn't want to waste resources on maintaining it, right? So that, my friends, is how we learn, and this has been demonstrated. Again, I won't quote the researchers and this and that. If you don't believe me, you can look it up yourself, but it's been shown that that's how all animals, or all biological beings that have brains like ours, that's how they learn. Your brain starts when you're a baby by an explosion of neuron connections that it creates, and eventually, you reinforce these connections. You make new connections as you learn more stuff. Create new paths in your brain, and eventually a brain wants to be efficient, right? Because our species did not evolve in the same environment that we currently live in, right? Not in abundance, and we evolved in a context where efficiency was key, right? So anyway, point is that at the basis of the principle, when you learn something, your brain is making a connection easier by reinforcing the ion channels between the two neurons, and decreasing the activation threshold that will make one neuron fire. So I guess I didn't explain that part, so I'll speak a little bit more about it. What determines whether that path actually works, and you go through and you can figure out how to add 2 plus 4, right? That's a bad example. Sorry, I'm trying to gather my thoughts again. No script is an issue. So the way it works is that as you how the connection is established or not is dependent on it's kind of like a light switch, where on one side of the dendrite you'll have some, I'm simplifying it, but a certain amount of positive ions, let's say, and on the other side, on the other dendrite, for the other neuron, you'll have a bunch of negative ions. And if you accumulate enough electrical energy, or if when you activate the first neuron, that activates enough positive ions that you can make the connection that you exceed. I'm imagining a bridge that's kind of being built from both sides, and if you put enough energy into the first side, that'll allow. And there's a little gap at the top of the bridge. Sorry, I'm building the image as I'm talking about it. So, yeah, there's a bridge, but there's a gap in the middle of the bridge between the two neurons. And you're driving your little car for your idea of trying to figure out, how do I add 2 and 3? And your little car, if you give it enough speed, if the gap, sorry, I'm really struggling with trying to make a clear image, and I'm revising the analogy as I'm speaking. So, okay, you've got a bridge again with a gap, and whenever a neuron activates, it launches a car at 60 miles an hour towards that bridge. And if you've reinforced or added enough connection or enough, if you've reduced the resistance enough, so if you've kind of shortened the gap in the bridge enough that your car can jump and land on the other side of the bridge, then on the neuron on the other side of that bridge will now activate itself and launch a 60 mile an hour car down its neurons to all the other neurons to which it connects, and then those 60 mile an hour cars will reach that next gap or those next gaps, and if 60 miles an hour is fast enough to jump the hole, well, then that'll activate the next neuron down the line. If it's not, then it just stops, the signal stops there, and that's it, right? So that's how our brain transmits information. And I'm sorry for butchering this explanation. I'm sure there's neuroscientists who could explain it much more with a much better illustration than I can. But hopefully you get what I'm trying to say. So as you learn is you're making the gap between the neurons smaller so that the car can make the jump. And as you don't use PATs, you're making that gap wider, and the car will just jump into the hole, and the signal, the potential, doesn't reach the next neuron. So that is exactly how resistors and transistors work, right? Transistors, as a lot of people point out, they're binary. They're 1 and zeros, right? But what was a big innovation that came with neural networks is they realized that, hey, we can put a variable resistor or resistance in between each transistor that will determine, whether when you switch that first transistor from 0 to 1, does that carry over to the next one or not, based on the resistance. Same principle as I just said, right? If the resistance is too high, the gap in between the two sides of the bridge is too large, and the 60 mile an hour car can't make the jump, so the next transistor doesn't get activated. So that again is a mechanical version of the way, or artificial version of exactly how our neurons work. It's not just the 1 and 0, yes or no, binary, as in the old traditional systems of a computer, as what your computer, the way your computer works right now, right? That's not how neural networks work. Neural networks go and they add that component that changes the resistance, and it's a variable resistance, and it basically acts the same way as our brain does. So what you do when you quote unquote train a system is you put an input, and then you just wait for the output of the system. And if the output is what you were looking for, then you give it a pat on the back and say, hey, that was great, good job, you gave me the right answer. And if it isn't, well, then you also tell it and you say, hey, that's wrong, you need to adjust something, try again. And you don't tell it necessarily, like in some older, or in some paradigms you can, or you do, but in general, you don't tell it, hey, go to transistor 76 and reduce the resistance by 0.3 and run it again, right? That's not how it works, or not how it should work. The way it works is you just say, hey, wrong answer, try again. And the computer will try again. It'll change something. You don't even know what necessarily. But it'll change it, and then it'll try, and it'll give you a new answer. And again, you give it more feedback. Is this the right answer? Yes, no, okay. Try again, or good job, right? And you know what? That's exactly... Oh, Daisy really wants to go home. Sorry, I guess we're going this way. That's the exact same way that a teacher will teach you how to add, right? What's 1 plus 1? 3. Oh, no, sorry, Timmy. Try again, right? What's 1 plus 1? 2. Oh, great, Timmy, you got it, right? Let's move on, or let's do another example, right? So, and Timmy, or your neural network, might get the correct answer for 1 plus 1, but then you train it more by giving it a new problem, right? What's 2 plus 2? Or 2 plus 2 is 3. Sorry, Timmy, no, you're wrong. Try again. And it'll adjust, and Timmy will adjust the way he thinks, try again, just like your neural network will adjust its resistances, try again, and will again try and see, hey, also, when I did, now that I've changed these values, if I go back to the 1 plus 1, am I still getting the right answer? Yes? No? Oh, crap. Okay, well, clearly what I changed wasn't the right thing to change, right? Oh, so let me try again, etc. And you do this, you iterate this millions and millions of times, and that's how humans learn. That's how ants learn. That's how computers or neural networks learn. Sorry, I have to get Daisy in. I think it's been long enough of a walk. I guess this will be just really part 1. I wanted to go a lot further, but consider this, I guess, the intro on AI and how, but more about how human and natural brains work, and how you can emulate that in a computer. Which will be the basis, I guess, for part 2 tomorrow, explaining a little bit more about how AI actually works, and why it can learn the same way we can. So, thanks for listening. Sorry this was a little bit convoluted. It's a complex topic that has a lot of background knowledge required, and I struggled to summarize what I was trying to say, but I hope you got something out of it, and please look forward to part 2 tomorrow, where I explain and go a little bit more about actual AI now that we've got the background out of the way. Thanks for listening. Please give me all your comments, suggestions, complaints, and insults, and do all the social media stuff. I appreciate your time, and thanks for joining me on the dog walk.